Hi, everybody, and welcome to my new series, which I title Research as Code. This series is for anybody who does academic research, any kind of research really, that involves running code and writing up the results. That's a pretty broad tent, but I'm thinking grad students, even professors, research assistants, some data scientists, and I'll tell you up front what the premise of this course is. Most researchers, particularly those coming out of academia, are taught the basics of how to do things in code. They're taught how to manipulate data, how to run loops and manage variables, do data wrangling and processing, draw figures, create tables. But they're not taught how to manage a software project across its whole life cycle. It's maybe a little bit like someone being taught how to go hammer nails and then being asked to go build a house. There's a whole lot that software developers know and learn and are trained in that researchers aren't. And if you are doing technical research, writing code, writing up the results, you are managing a software project. And I have a background as a software developer. I did my PhD in political science at Stanford, which was a very data science heavy program, but I also have been a lifelong coder and in my most recent job founded and led a software development team. So I've learned an awful lot from the software side, and I'm super passionate about the lessons learned there. There's been a lot of work done in the tech world identifying best practices for how to manage software. And other scholars have come in and studied the difference between teams that embrace those best practices and the teams that don't. And the results are staggering. The teams that adopt leading practices for managing software often outperform teams that don't by an order of magnitude of the thousands. They develop code thousands of times faster in some cases. They have thousands or hundreds of times more reliable code. If something goes wrong, they're able to recover hundreds or thousands of times faster. So there's a stark difference. And when I look at that world and I look at how researchers typically do it, there's a huge gap there. And what I'm passionate about is helping others, particularly newer grad students and younger professors, learn how to do this stuff because it makes your life so much easier. And I'm speaking from experience because I climbed this hill myself. The way that I started writing code as a grad student and the way I do it now is completely different. So, and the results of that have been absolutely staggering. I'm so much more comfortable now in how I manage my work. So to make this more real, think about whether you have ever done any of the following. Have you ever written successive drafts of your paper titled Research Paper Version 6, Research Paper Version 7, and ended up with a whole host of files scattered everywhere? Have you ever been unable to replicate a table or a figure and stayed up till all hours trying to figure out how on earth you got that result so you can prove to your advisor that yes, this is legit? Have you ever come across a number in your paper, 26.8%, and asked yourself, where did that come from? I cannot find it anywhere in my code. Have you ever dug through a source file, which probably won't run in its entirety, but because you've been running in chunks out of order, and you've got all kinds of stuff in that file, commented out code, old code, experiments, trying 3 different ways to do things, and at the end of the day, you have no idea if that code will run, what order you're supposed to run it in, and so forth. Have you ever got so far along in a research project, maybe it's the week before it's due, and you realize there's one bad data point in your original data set that needs to be fixed? And that one change will force you to recreate everything. You're going to have to walk that data set through the entire process of hand generating every figure, every table, copying and pasting it into your LaTeX document, whatever your final report is, and dealt with the long hours of that, and then maybe had another change after that and got trapped in this rhythm of constantly being behind, trying to deal with the latest challenge. Have you ever got that far along and realized you had a software bug, and this whole time something upstream was rendering all of your downstream conclusions incorrect or moot. So these are quite common problems. I've been there, I've done it. I'm going to show you some of my own original work. But what if there's a better way? What if you had complete confidence that every change you ever made was tracked in a version control system that you could roll back to any state prior and you could see what's changed and you could safely delete all that extraneous code because it's all saved way back in a version control system? What if every single time you saved your code, one code file anywhere in your project, your entire project from start to finish rebuilt itself? Every table, every figure, every number, your paper, so that you could make the slightest change. If there was one data point wrong in your data set, you could fix it, save, and your paper with all of its dozens of charts and tables and figures would regenerate itself instantly. What if you had complete confidence that every piece of your project would run every time you saved it, so that if you made one mistake, you would catch it instantly and never, ever, ever have broken code? These are the kind of best practices I'm talking about, and this is what software developers do in today's world. They have figured out how to automate everything, how to build an entire project from start to finish. Every time you make one change, you make a spelling error in your code somewhere. Well, what if you accidentally, in your effort to fix it, broke something? Those are the kind of problems that plague bad software developers. Good software developers have a whole build system that will catch that immediately, so those kind of regressions never happen. And you can do all this. It does take some learning up front. You will slow down in the beginning as you're learning the skills, and you might be asking yourself, why am I wasting my time on this? Let me just go back to the old way because it's easy to me. It makes sense. Well, the payoff comes over the long run when, instead of spending 5 hours the night before something is due trying to regenerate all your code, you can fix those mistakes in seconds and confidently move on to the next thing. Eventually, you start to feel such a sense of safety and security in the process that you can't do it any other way. So in this first video, I'm going to show you two examples, a bad example and a good example. And I actually did the good example first because it's how I think now. It's natural to me. When I had to go back and create a bad example, it was so painful to force myself to do it that way. I felt sick and ill and embarrassed at my own code doing it this way, but that's how most students are taught to do it, or at least they're never taught any better. So let's dive into a good example and a bad example. And after that, what we'll do is we will go back to the beginning and we'll take our time over a series of videos to figure out what's entailed in this and how to do it. And I hope this will be helpful. I hope it will transform the way you do research, make you a better researcher, a better developer, but also more at peace, that you can worry about your research and not worry about just fixing broken stuff all the time. The last thing I'll say before we dive in is this is not for everybody. If you are in the humanities, if you're a historian, if you're someone who writes lengthy documents, doesn't need a lot of math, doesn't write code, this is probably not what you need. This really is oriented towards anybody who is taking code outputs and putting them into a research paper, or at least where one piece of your work gets passed downstream through stages into other pieces. That's where the software comes in. It's that chain of manipulating data. I'm going to talk about LaTeX. I will assume that's what you're using. Some of this may apply to Markdown, Pandoc, or other systems like that that treat text as a kind of code. And my examples will mostly be in R, but I will also throw in some Python to try and help people out who work in both languages. But what really matters here isn't the languages themselves, it's the process and the principles, which work in any language.